Alright guys, so today we're actually going to learn about something that's brand new and it's actually one of my favorite things to teach and I think you're really going to enjoy it. It's called the Pythagorean Theorem. And the Pythagorean Theorem speaks specifically to geometry and right triangles and what we already know about equations and square roots and inverse operations. So first things first, this is a right triangle. Alright, we know it's a right triangle because it has a right angle right here in the corner. And the measure of a right angle is always 90 degrees. You can tell because it has this nice little box here in the corner. Also, if you take your piece of your paper, you can slide it right into the corner right here, and you can see that the corner of your paper fits right into that little spot, and you know it's 90 degrees. Additionally, about 2,500 years ago, a Greek mathematician named Pythagoras discovered a special relationship between the sides of the right angles of a right triangle. Pythagoras realized that if you have a right triangle and you square the lengths of the two sides that make up the right triangle, so this 3 and this 4, then you add them together, you're actually going to get the same number you would get by squaring the other side. So 3 squared plus 4 squared is going to equal 5 squared. Is that correct? Well, yeah, if I square 3, I get 9. If I square 4, I get 16, and that equals 25, which is 5 squared. Kind of cool. Now, this is true for any right triangle. So for example, right here we have 8 plus squared plus 6 squared, which equals 36 and 64. Add them together, you get 100. Well, that's the same as if you squared 10 right here. Now, the two sides which come together in a right triangle are called the legs of the triangle. All right, and instead of just calling them the legs, we also usually call them by the variables a and b. Now this is important to understand. Right here, this is labeled A. Right here, this is labeled B. You can definitely switch them around. This could be called B. This could be called A. It doesn't matter because they're both legs. Now, the side across from the right angle, so directly opposite of the right angle, is called the hypotenuse. Whoops, let's go back. Sorry about that. And the length of the hypotenuse, we usually label it C. So the legs are A and B, and the hypotenuse, which is the side opposite of the right angle, is labeled C. And this relationship that Pythagoras discovered is now called the Pythagorean Theorem, or a squared plus b squared equals c squared. All right, so let's see how this works in action. Suppose you drive directly west for 48 miles, and then you decide that you're going to drive south for 36 miles. How far are you away from your original destination? How far away from where you actually traveled? Well, we can actually use the Pythagorean theorem to help us figure this out. Notice how our word problem has formed a right triangle. Using the Pythagorean theorem, we can find out what this original length is. So here's my leg, 48, so I'm going to square that. Here's my leg of 36, so I'm going to square that. And that's going to equal c squared, or our hypotenuse squared. All right, and once again, can't you see that we're making a right triangle here? We drove 48 miles west, we turned and we drove 36 miles south. Now, like we already said that these sides are the legs, 48 and 36 are the legs. We know that C is the hypotenuse. And so now all we need to do is calculate. So if I take 48 and I square it and I add to 36 squared, I'm going to get 2,304 plus 1,296, and that equals 3,600. and 3600 equals c squared. But we're not finished. Are we looking for c? No. C squared? No, we're looking for c. So if I actually, let me turn my pen on, draw my triangle, right? I know that this was 2,304 and this was 1,296. I need to know what c is, not c squared. So how am I going to get rid of that square symbol? Well, I'm going to do the inverse, which is to take the square root, and you guys should remember that from earlier in the year. So I'm going to take the square root, remember this little symbol, of 3,600, and I'm going to get 60, and you can use your calculator to do that. So since this c squared is 3,600, 60 is the square root, so we ended up 60 miles from where we actually started. And you can see that this actually would have been a faster way to go, because instead of going straight across and down, because 60 miles is shorter than 48 and 36. And you'll always notice that in a right triangle, if you add the legs together, they're going to be bigger than the hypotenuse. If they're not, that means you don't have a right triangle. So let's find the length of the diagonal of the rectangle here below. We want to know, what is the distance across here? Well, we can notice, hey, we've actually made not one, but two right triangles. Our leg lengths are 8 and 15. What's c? Well, put them into our formula, a squared plus b squared equals c squared. We get 15 squared, which is 225, plus 8 squared, which is 64. So c squared equals 289. Use your calculator in that square root function, and you're going to find out that the square root of 269 is 17. So the length of this is actually 17. Boom. Got it. Now, we're going to take a moment and practice using the Pythagorean theorem. Go ahead and pause the video now. And excuse me, no, don't pause the video right now. Go ahead and try to find the missing length of this side. If you need to pause the video, go ahead and pause the video. When you're finished with this problem, raise your hand so I can check it. Okay, go ahead, try this problem. Pause it, pause the video now, and try to find the side length of B.